Für einige Jahre studierte ich in Deutschland im sogenannten Großen Kanton der Schweiz und habe dort auch ein paar Besonderheiten über die Schweiz kennengelernt, wie zum Beispiel Grüße miteinander. Americans, we try. We do our best, right? So my students tell me that I'm a lot more interesting if you're fully caffeinated. So hopefully you've all had an opportunity for your coffee breaks. So at my university, we have 35,000 students. And we have students who are studying advanced analytics and data science at the undergraduate, master's, and PhD level. And across all of our programs, at every level, we're heavily integrated with corporate partnerships. Corporate partnerships really form the basis of everything we do in advanced analytics. And so frequently I'm asked to go different places around the world, wonderful places like Switzerland, and talk more about how corporate university partnerships are really influencing and forming what we now know as the practice and the discipline of data science. So that kind of forms the remarks of what I'm going to be going through today. So it really almost doesn't matter what you put here on the y-axis. Everything that we see in the data science space kind of forms this graphic. So we've had a lot of people this morning talking about conversations in data science and the size of the files and the complexity of the data. And I know you are all engaged in data science in different ways. How many of you are on LinkedIn? So can I just say LinkedIn kind of cracks me up because, on like a Friday I'll see somebody's profile and they're a poet. And then on Monday they're a data scientist. Right? Everybody is becoming a data scientist, and a lot of that has to do with this graphic. And so one of the questions that I get from companies quite frequently is kind of why now? Why are we seeing this explosion now? Which ultimately is informing why we're seeing this close relationship that's forming between universities and the private sector in particular in a way that we've never seen before. Well, one of the reasons is because everybody's really chasing the same talent at the same time. And so let me give you an example of that. Within the context of our own university, we will have the same student who's being recruited by a hospital organization, and by an engineering organization, and by a retailer, and by a marketer. The same student is being recruited by all of those different types of companies. And you might say, well, that makes no sense. Those are completely different disciplines. Those are all completely different types of organizations. But the reality is everybody is trying to chase the same talent at the same time, right? Everybody, whether you're talking about the healthcare space or you're talking about the engineering space and manufacturing and marketing and finance, everybody's trying to do the same thing. Everybody now is trying to deal with this massive amount of data, structured and unstructured, and translate that data into meaningful information to inform the decision-making process. And that's the same regardless of what part of the economy you're dealing in. And that's why we're seeing what we call the employment equivalent of a run on the bank. Everybody's trying to chase the same talent at the same time, which is why everybody's translating their profiles on LinkedIn from being a poet to a data scientist, because everybody's trying to chase those people. So again, back to the question of why now? Why are we seeing this now? Because the reality is we've always had big data in the sense that if you're old like me, back in the 80s, when computers first came out, you may have had a computer that had 64K of memory, right? My students don't even understand what that is. 64K of memory doesn't even make sense. But if somebody gave you a big data file of 128K, you had a big data problem, right? So it's not just about the size of the files, as we've now heard multiple times already this morning. the types of the data increasingly are not only are they different, but they're constantly expanding. So further to some of the points that Olivier made earlier, the way we're defining data is changing, right? The ways we talk about data are changing. You know, the types of skills that it takes to translate this kind of data and the laws that we've written to protect and defend and deal with this kind of data is very different than as we move across all these other types of data, right? The skills that it takes to translate cross-sectional data are very different than the types of skills that it takes to translate image-based data, or video data, or geospatial data, or text data. These are all very different types of skill sets, right? And so the educational sector, the academic sector, is really trying to play catch-up to what's happening in the marketplace in terms of how the data is defined and how the data is being generated. And then, you know, the private sector is coming to us saying, hey, we need the talent to translate all these different types of data into information to solve our problems. And we're saying we're doing the best we can. We can only produce the talent so fast. And by the way, right now, nobody in the world has a PhD in data science, right? I mean, think about that for a minute. Nobody in the world right now holds a PhD in data science. Now that's changing because universities are starting to pivot their curriculum to try to address that issue. But as we stand right now, we have this huge gap, right, between what the private sector needs and what universities are ultimately able to provide right now. And I'm going to talk more about that in just a minute. So this issue of all of this data, this structured and unstructured data coming in massive quantities, and everybody's trying to chase the same talent at the same time to accomplish the same objectives, right? To translate all this data into information to solve business problems, all at the same time is creating massive challenges for companies. And I'm sure, you know, if I took a poll and asked everybody in here, do you have an open position right now for a data scientist? Everybody would raise their hand, right? Everybody's trying to hire the same people. And so this is creating challenges for companies. So the first has to do with the talent pipeline, right? So we constantly have companies who are coming to us, and it's just not our university, it's pretty much every university around the country. We have organizations like yours that are coming to us and saying, hey, I have openings for 3, 5, 10, 20, 100 data scientists that I'm going to have to close over the next couple years. Can you help us fill this talent pipeline? Well, that would be great if that was one company. But we have literally dozens of companies who are coming to us wanting to build this talent pipeline. Remember what I said, there are no people in the world right now who have PhDs in data science, right? So we have this issue of, we have the companies coming to us asking for the talent. We're doing the best we can with what we've got, but the reality is most data science programs are sort of sitting at this intersection of mathematics and statistics and computer science within some area of application, and we're having to kind of put all these things together in order to build these data science programs to try to fill this talent pipeline. But it's definitely a challenge. The second challenge that we see, which actually is sort of a different take on the same issue, is training the existing workforce. So what does that mean? That means that it's not just about bringing in new talent, right, to deal with all this data, but importantly now we're seeing a lot of companies who come to us and they say, look, we've got a lot of smart people that work at our organization, but they've been out of school for 15 years or they've been out of school for 20 years, and we need for them to go back and refine and retool their skill set. Right? So if the only type of analysis that you studied 20 years ago was Excel, and you know how to deal with 100 observations and 3 variables and clean data, the reality is your skill sets are very much out of alignment with what's happening in the marketplace, right? And so a lot of the challenges that we get from companies has to do with retraining the existing workforce. So now we've got the challenge from the private sector coming into the academic sector saying, not only do we need for you to help us build the new talent pipeline, but we also need for you to retrain the people who are currently within our organizations. And the third point that creates a challenge with all this data for these companies has to do with research and development. So, I've got all this data, I don't even know what the right question is, right? So let me give you an example. We do a lot of work with Equifax. If you know who Equifax is, they're sort of a data repository for credit, for consumer credit, but also for commercial credit. They came to us recently with a challenge having to do with the democratization of credit, of giving individuals who are in like third world countries and less developed countries who may not have access to a centralized banking system, how do you democratize and create potentially like a peer-to-peer lending network within countries like that, right? How do you solve for that? So one of the big challenges that's associated with peer-to-peer lending is this whole idea of verification, right? Of ensuring that you are who you say you are, right? And so if you can imagine, Equifax has all this data, again, structured and unstructured, and they have data, access to data that's kind of exogenous to the credit and the banking framework, and they don't even fully understand how to articulate the question, but they just kind of throw it to us and say, here's what we're trying to figure out. Help us, put your PhD students on this, put your faculty on this, and help us solve this problem, right? And so that's an example of sort of a big data science-oriented research question, but I could multiply that by every company that we've ever touched is trying to figure out, again, how to work with all this data, how to improve the decision-making process, and ultimately how to improve their bottom line. So these are sort of the main challenges that we see when organizations come to us and say, we've got these issues that we're struggling with within the context of the private sector. Hey, you, Mrs. University, can you help us address these, and what can you put together to help us close this gap? So the challenges for educators, where all these things are going to come together. By the way, I think I had this guy as a professor when I was an undergrad at Georgia Tech. In fact, I think he still looks like that and still teaches like this, by the way. So challenges for educators, number one is content. And so what do I mean by that? So when we talk about data science as a new discipline within universities, theoretical data science doesn't make sense, right? Data science, by definition, is an applied discipline. And so we can certainly go to things like Kaggle and KDD Nuggets, and those are great opportunities for our students to engage in international competitions, and that's a lot of fun. But the reality is nothing is more valuable than having a company come into the university and say, here's my data, here's my problem, here are 3 pain points that I'm trying to figure out. Can you put your students on this problem and help us address what it is that we're trying to solve? Bring the content, the data content, and the specifics of the problem into the classroom, we find is the best practice. That's the right way to teach. Theoretical data science, where you have them open up a textbook and have them derive formulas, is not the right way to teach data science. And so the challenge then for educators is to reach out to the private sector to say, hey, bring us your data, bring us your problems, bring us your challenges, such that we can bring it into the classroom for the purposes of teaching. Plus, what's really fun about that as a professor is I don't have to do as much prep because I can have you guys come in and help structure the class. But again, that's constantly a challenge for us. The second challenge that I've already kind of alluded to is this idea that there's nobody on the planet right now that has a PhD in data science. So let me tell you a dirty secret about professors. We love to think that we're the smartest people in the room. The reality is, as we start talking about data science and all the new things that are happening in this space, we need you guys to come into the classroom to share what you're actually seeing in the real world. Because you guys are experiencing and dealing with the day-to-day challenges of having to deal with massive amounts of data and translate that into information in your space. And that becomes a very valuable set of exercises for the students, far more valuable oftentimes than what their professors can tell them. The third point here is funding. So So we're always looking for opportunities to bring additional funding into the university, right, to support specifically PhD students, but master's students and even undergraduate students. Students are very expensive. They take a lot of care and feeding. And so what we find is that this funding gap is really important, and I'm going to talk more about that in just a minute. So this idea that this new space that we're in with respect to data, right, to data science and to all these different types of data and the size of the data and the velocity and the variety and some of the things that have been alluded to earlier, that this has now created not only a set of problems and challenges for the private sector, it's created a set of challenges and problems for the academic sector. And for the first time, we have this amazing opportunity to work together to address these challenges as a team. And so you can see this quote, there's an increasing permeable membrane between academia and the private sector. That was actually me that said that. But one of my students gave me this cartoon. I'm like, oh my gosh, that looks just like me. So my students like to throw that out there. So let me talk about how this is changing the academic sector, and we're seeing this over and over again in universities all across the world. So the classic university is kind of structured like this, where the predominant source of funding is from the government, from the public sector. The primary orientation is academic. It used to be that you wouldn't see conferences like this, where you see some professors and academics and some people from the private sector. For the most part, those two things were very discrete and separate, and you wouldn't see the two blending. The degrees historically have been very department-oriented, so my guess is, as any of you were going through your respective academic careers, you probably only took classes with people that were studying whatever it was you were studying, right? Universities are very good at being siloed historically. Blue sky research, just kind of whatever it is, the professors want to go out and research, and single author publication historically has been a really big thing for academics. But all this is changing in large part because of what we now see in data science. So rather than a classic university, now you might start hearing the term entrepreneurial university, where universities really are starting to pivot away from the public sector and more towards the private sector. And then you can see how that flows across all of these. So, specifically as we talk about orientation, within our own universities in the United States, you're seeing a lot more universities that are reaching out to their respective constituents with the companies that typically hire from them most frequently, and they'll say, bring me your job ads. Bring me what you need over the next 3, 5, 10 years in terms of talent. Help us pivot our curriculum to ensure that we're meeting the needs of what you guys are going to be looking for as it relates to data over the next couple years. Interdisciplinary degrees. So again, data science isn't a single degree that sits inside any individual department, right? Data science is a great example of an interdisciplinary nascent discipline that sits at this intersection of multiple disciplines, like again, mathematics and statistics and computer science, typically with some application that's coming out of the business school or it's coming out of the medical school. Research tends to be now directed, where we'll have private sector companies come to us and say, here's a specific problem that we're trying to solve, like the example that I was giving with Equifax, and we can give you some research funding to support that, and that becomes an important now part of our calculus within the university. And multi-author publication, again, this is indicative of an entrepreneurial university, where you'll see publication that's coming not just from multiple parts of the university, but also with private sector collaboration. Okay, so when we talk about collaboration between universities and the private sector, what does that look like specifically? So I'll go ahead and animate this in terms of kind of what we see. So if you look at tactical versus strategic, and then the amount of resources that are required to engage, this is true whether you're talking about the private sector company or you're talking about the university. On either side, tactical and strategic versus required resources. So, we've always had things like student internships, right? That's always been a thing. with universities. But as you start to move from the southwest corner up to the northeast corner, things become more indicative of the entrepreneurial university and certainly indicative of what we see with the collaborative landscape in the data science space. So I want to specifically highlight 2 points here in terms of modes of collaboration that we've seen a lot of within our university. So the first is the shootout class. So the way these shootout classes work is an organization will come to us and they'll say, again, in the beginning of the semester, here's my data. Here's 3 things that I'm trying to figure out. Here are 2 pain points that I'm struggling with. And here's a couple things you need to know about my domain, about my space, about my competitors, or about something that's going on in my market. Here's my business card. I'll see you in 15 weeks. And this is the shootout class. And so then behind the scenes, what we do as faculty is we will put they're typically master's students, we'll put these master's students into teams, collaborative teams, where we'll try to draw from, again, computer science and mathematics and statistics, and then maybe marketing and finance, and we'll put these kids on the same team. I can say kids because I'm somewhere between 49 and 50 for 3 more months. So we put these kids into teams, and then we'll also typically put a PhD student on the team as their kind of advisor, right? Which again works really well because then the professors can kind of sit behind the scenes and just call us if you need us. But then it tends to work really well. The course tends to be customized to whatever it is the company needs. And then at the end of the semester, the students have an opportunity to do kind of their 15-minute presentation, right? They get to stand up in front of the companies, they get to present their model, they get to present what it is they found within the context of the data. And then importantly, you can see this last point here, screen candidates. So back to the idea of the talent pipeline, right? This is a great opportunity for these companies then to screen candidates in a very real-world context and gives them an opportunity to see what people can actually do with their data. And so we tell the students at the end of the semester, it's not about the grade, it's about the job. So at the end of the semester, when the kids get up there and then they present their findings, typically the project sponsor will say, good presentation, I want to hire him and her. The rest of you can go away. But that tends to be kind of the outcome, and we do this every semester, and it's probably one of the most successful things that we do within the context of our data science program, because again, it gives the students the opportunity to, again, translate massive amounts of real-world data into information to solve a specific problem in context. The second is what we're calling the Equifax Data Science Research Lab. So this is those research labs that are way up in that upper right-hand corner, right? This definitely takes the most amount of resources from the company, and it takes the most amount of resources from the university, but ultimately this is probably one of the best methods of collaboration that we've seen. These are all PhD students who are working in the Equifax Data Science Research Lab. Again, typically works best with PhD students. The company, in this case Equifax, gives us a grant, just like we would get a research grant from the government, from the National Science Foundation or from the National Institutes of Health. They give us a grant, and they say, within this grant, we want you to address these 4 questions, and off of those 4 questions, then we're going to be looking to monetize the results. We're going to look to operationalize the algorithms. From our perspective, we're looking to be able to publish and create peer-reviewed publication off of the results, etc. But these typically are again, kind of up in that upper right-hand corner because they take the most amount of resources, the most amount of time, but ultimately it's the most strategic. Okay, so those are kind of 2 case study examples, but whether you're talking about collaboration up in that upper right-hand corner or collaboration down in that southwest corner, there's things that need to be considered when universities and private sector companies are collaborating. The first is to have very clear objectives and very clear expectations and understanding. I spent several years with Accenture, and I can tell you that putting together a consulting team at a top consulting company and putting them in a company is very different than taking a group of master's students and putting them at a company to solve a problem. The master's students are a lot cheaper, but there needs to be very clear objectives and very clear expectations in terms of what you're ultimately going to deliver. The second point here is professor-student. So this is one that we constantly get conversation with these companies on, is when a company hires us or engages us in a data science-oriented project or research initiative, we have to be very clear. You're not hiring the faculty, because we're a lot more expensive. You're not hiring the faculty, you're hiring the students. And again, that needs to set expectations in terms of what the final deliverables are going to look like. Intellectual property. So this gets to some of the legal points in terms of who owns the data, who owns the output, who has access to the data. Does it need to be a whitelist? Does it need to be a blacklist? Does the data need to be destroyed afterwards? And can we use it for teaching purposes? Intellectual property is something we have to spend a lot of time on in the very beginning. Publication. So when universities engage with the private sector, certainly as you move from undergraduate to master's and up to PhD, as you move up that continuum, the universities are going to be looking for opportunities to publish the results. So if a company says, no, you absolutely cannot publish anything that we're working on, we're going to charge them a lot more money. But if they're going to allow us to publish the results, even in a generalized format, usually we're going to have an opportunity to charge less in that context. I've talked a little bit about data privacy and clear deliverables. All of these are very important things to consider as you're engaging private sector and academia, because everybody kind of comes in with different expectations and different lenses in terms of how these initiatives work. And frequency of contact. This is something that I'm constantly working on with our students. These students like, especially the ones that are coming out of like computer science, they love to take the project and then go sit in their lab and never talk to anybody about it. And they're like, I'll call you when I'm done. I'm like, honey, you can't do that. When you're dealing with clients, you're going to have to give them feedback on a regular basis on what you're finding and give them regular reports. And so that's definitely a point of learning for the students. So I wanted to go through this quickly to see if anybody had any questions, or if you wanted to talk about maybe some of the other points of collaboration that I highlighted up there. I wanted to highlight two specific case studies that we've gone through, but I'd be happy to engage conversation. Yeah, go ahead.
So I'm just interested in more details about the giving a one-year grant for PhD student to work on your projects.
Sure.
Because obviously it would be extremely cheap. I mean, from what I know what my friends are making as PhDs in the US, it would be about a year of funding would be equivalent to like 3 weeks of me as a consultant.
Right.
And so from that perspective, why isn't everybody doing this constantly? Why is anyone ever going with consultants
Right.
if you could get a PhD somewhere to work on your stuff?
Yeah.
So what are the trade-offs there?
Yeah, sure. It's a good question. So, let's talk about it up here, right? So let me talk about some of the specifics, and then I can talk about some of the strategies. So within the context of our own PhD program, the PhD students are not allowed to work while they're going through their PhD program. That's typical, I think, of most PhD programs in the United States, is that they tend to be full-time. Because to be honest, they're very intense, right? I mean, it would take you substantively longer if you try to do it part-time. And so we tell the students, this is going to take you 4 years to get through it. So just plan on the next 4 years. We own you for the next 4 years. I'm going to get tired of you after 4 years, and I guarantee you're going to get tired of me after 4 years. So let's make sure that you're out after that. Now, having said that, because they can't work, we pay them a stipend, right? So the university pays these students a stipend of $36,000 a year, or $3,000 a month, right? Now, you and I both know that that's substantively under what their market value is, right? They're engaged in research and teaching, and they're studying. We also give them a tuition waiver. And so by the time you factor in the tuition waiver, now they're up to more like $55,000 or $60,000 a year, which again is still substantively under their market value. But the intention is that they're focused while they're going through their program. So when we do these big research labs, typically what we'll do is we'll partner with an organization, like I said, with Equifax. So with the Equifax Data Science Research Lab, which is out on our website, they gave us a grant of $75,000. And in the context of that $75,000, they're basically hiring 2 PhD students, and they're hiring a fraction of a faculty member, basically. And then over the course of the next 12 months, we have a list of deliverables and things that we have to be able to provide back to them. And we're also co-authoring publications with them over the course of the year. The intention is that that's a proof of concept and that'll roll, right? So we're hoping to renew at the end of the calendar year. So to your question on why would an organization ever go to a private consulting firm versus working with a university? I came out of Accenture, so I've kind of seen this from both sides, right? I mean, the thing about working with a university is, you know, with the students, they've got other responsibilities, right? So they also have teaching responsibilities, they have class responsibilities, and so although they are living, eating, breathing, sleeping this organization's problems, ultimately they also have other things that they're engaged in. So, so the timelines tend to be longer, number one. Number two, you know, when Accenture walks into an organization, we walk in as an army, right, with 50, 100 people, and we will knock out a 3-week engagement, but it'll cost $1 million, right? With these PhD students, it's going to take 6, 9, 12 months, but it's just those 2, and it's going to cost $75,000. And then again, the deliverables tend to be different. The deliverables tend to be much more aligned with thought leadership, right, versus kind of immediately creating some massive algorithm that then can be operationalized and monetized straight away. And then in addition, the partnership with the university, they're not just in this altruistically. They're also looking to screen candidates who ultimately can come in and be part of their R&D organization.
So just in summary,
Yeah.
if I understood correctly,
Sure.
there's no incentive with going with consulting firm if what you're doing is a project that has a long time frame and is looking for actually new ideas, not necessarily operationalizable code, but then the other scenarios are for the consultants.
Yeah, I think I think that the roles are different, right? So if you're looking to engage with a university for the purposes of like thought leadership and publication and R&D, you know, that makes a lot of sense. If you want to engage a university to bring in 100 people to come in and rewrite code that can be operationalized straight away, you know, that's not the right solution. So I would say it depends on what you're trying to achieve. Yeah?
So we were talking about this, mostly the talent drive towards the industry. So when you come out of the academia after the all the education to go to and then there's a big need for that and big drive. So how many good people actually want to stay in academia?
Yeah, it's a good question. So, excuse me, back to the idea of the classic university versus the entrepreneurial university. So it used to be that if you were going into a PhD program, you were going to go into academia, right? Full stop. That's just what people did. But increasingly, you know, it depends on what statistics you look at, but when you look at data scientists specifically, you know, a substantive percentage of data scientists have PhDs. They don't have a PhD in data science. They have a PhD in something, and now they're calling themselves a data scientist. Back to LinkedIn, right? So we're seeing a lot more PhDs go into the private sector, but increasingly we're also seeing individuals that want to do both, right? So we see a lot of students who come into our program who say, you know what, I want to go through this process. It's my intention to go to work for, you know, an organization and be a part of their R&D group, but then still have an adjunct position with a university. So it's almost like they want to have a foot in both doors. But I would say that within the context of our own program, probably 80% are intending to go into the private sector in some way, and maybe only 10, 20% ultimately just want to become full-time academics. And part of that's because of, you know, the money, to be perfectly honest. But I think it's also because the private sector is increasingly bringing in PhDs for the purposes, again, of R&D, and having almost this quasi-academic type position where they're engaged in research, but they're still in the private sector, and they're being compensated like they're in the private sector. Yeah?
I have a question about data protection and,
Sure.
and IP. In your experience in practice, how does that look when you've had a lot of contact with companies that come and want to cooperate on some issue? How's that resolved usually?
Yeah.
Because by my experience, very often this is a tricky issue, a lot of stakeholders and
Yeah.
slowdowns. How does that look?
Yeah, it's very tricky. I've lost track on how many times my background's been checked at this point. There's a couple different ways that we work with companies on this. So we've got some companies that are like utilities, right, or like electric producers, or areas where maybe they're not dealing with people as much. Like we're doing a big project right now with GE Power. We were talking about this last night at dinner. So we're doing a big project with GE Power right now, and all of that data is related to big things, like big generators or big turbines or something like that. Well, clearly, we can't disseminate the information publicly, but there's no PII, there's no like individual issues there, right? Because we're not dealing with human beings. And so the types of protections that we have to put around that data are not nearly as intensive as when we're dealing with like medical records, for example. So let's use that example. When we're dealing with electronic medical records, not only do we have PII, but then we've got all the medical information. And so that when we deal with that kind of data, typically that has to go on a standalone server that's not connected to the internet. It typically is in a standalone room, and there's a whitelist of students that can work with that data. And what I mean by whitelist is if you're not on that list, you can't access the data. And those students typically will have to have gone through a background check in order to have earned the right to work with that data. The same is true roughly for financial data. So we just did a big project related to the subprime lending market. And in that context, again, we had all this financial data, we had social security numbers, all this PII, and all that data set on a standalone server. And again, the students were on a whitelist in order to access that data. In both of those instances, when the project's done, those servers have to be wiped and all the data has to be destroyed, right? On the other side, like we do a lot with utility providers, electricity generators and things like that, where you don't have PII. On that side, all we have to do is sign off that the work we're doing is for academic purposes, and that we can make the data publicly available to the students, but we can't use it for anything monetizable. So those are kind of the two ends of the spectrum. I don't know if that answered your question.
Yeah, I think it. So if I hear you right, the non-personal data is usually much less tricky in your response.
Yes, right.
There's also no concern about knowledge or insights about some practices that they're doing, even with non-personal data.
Yeah.
That the press hears, oh, there were inefficiencies. Even with non-personal
Yeah.
data, that can make a company look
Yeah,
bad.
sure. So there's two levels to that though, right? There's the raw data, right? And then there's the information that you're able to derive as a result of analyzing the data, right? So the data itself becomes sort of an asset that they've effectively given to us that we can then teach from. There's nothing private about it. The results of the analysis, though, is private, that we give to them, that we don't share publicly. But the data is important. Back to the idea that data science is not a theoretical discipline. We have to have those types of data sets in order to teach, right? Again, at the undergraduate, master's, and PhD level. Yeah.
I had a quick question because you responded to another remark. You had this fact that there's no one with a PhD in data science. I think that, as you said, it's not a theoretical discipline, so it's a bit like programming. No one has a PhD in programming. The first people that were developing software were people doing PhDs in mathematics and so on. And that brings me to the next point, which is you need a theoretical development, or you need to fit from theoretical developments. How do you see those coming? Because those insights may not be coming from, unless it's Microsoft research, or some large organization like that, there's not people looking at the core of what is the actual new mathematical methods or new
Right.
methods that we need. Where do you see that sort of research happening in your landscape? Because
Yeah.
that's what's going to bring the technology forward in
Right.
the next 20, 30 years.
Yeah, no, it's an excellent question. So again, within the context of our own PhD program, the students have to take 12 credit hours, which is 4 courses, in PhD level mathematics, right? Which is theoretical. So they are having to take theoretical mathematics. They have to take theory of linear models. They have to take discrete optimization. They have to take mathematics for big data, which has to do with kind of algorithm development. And then importantly, they have to study graph theory, right? I mean, you saw some of the graphics that like Claudio put up this morning. You know, all that's grounded in graph theory. And again, those courses are very theoretical. And I get pushed back on that a lot when I talk at conferences or I'm working with other academics, and they'll say, why are you making these kids go through these theoretical math classes? Why are you torturing them with this? And I'm like, well, the torture is just the fun part of it. But the reason why we challenge them on these theoretical math classes is exactly to your point, right? It's not just, you can't just, so there was this hockey player, Wayne Gretzky, right? And people used to ask Wayne Gretzky, what makes you the greatest? He was the greatest hockey player in American history. He's actually Canadian, but we kind of claim him. So anyway, what made you the greatest? And he said, I didn't skate to where the puck was, I skated to where the puck was going to be. Right? And so I think that is analogous to what you're asking. So when we require that they go through all this theoretical mathematics that really underpins data science, the intention is to make sure not just that they can do what's in front of them, but ultimately that we can get them to where they need to be, and we don't even know where that is right now, right? But they need that grounding in theoretical mathematics in order to determine what the next thing is, which is different than just teaching them Python, right? Or teaching them Spark or Scala or SAS or any of these other languages.
Thanks.
Great. I'm getting the high sign, so I think I've bumped up against time.
No, it's okay. Actually, your slide said you wanted to show something different, but honestly, I kept you going and you going asking, because it's always very nice to have a lively discussion. So thank you for that. We have still 3 minutes, so please feel free to go ahead.
Let me maybe ask a question. So, as you have a lot of companies who come now to you, you certainly want to have a lot of software companies. They want to promote their software. It's the best one to use for
Yep, we get calls every
So
day.
how do you take into account this? It's not branded by a software company,
Yeah.
maybe SaaS or...
Yeah, so first, we're a huge SaaS shop.
Yeah.
We do a lot with SaaS, and we don't work with SaaS just because they're like the thing right now. We work with SaaS because it's strategic. It really is a strategic partnership. You know, SaaS is very much, back to the Wayne Gretzky quote, you know, they're not just skating to where the puck is, right? They're really, truly a thought leader in this space, and they're really a great partner, strategic partner. So, you know, that's been an important part of our calculus, and I think you'd probably hear the same thing from other universities. It's about developing a partnership with a technology organization that's going to help inform and shape your curriculum, not just bringing in the next software package that's the hot thing right now. But yeah, we get a call almost every day from a software company that wants to come and teach our students how to do their software so that they'll, you know, encourage that when they're employed after graduation. We typically don't respond to any of those because we're, like I said, we've really embraced our relationship with SaaS. I think you'll find some of the top universities in the United States have done that with SaaS as well, and I know several here in Europe and I guess around the world. You know, we also obviously integrate some of the open source languages, obviously Python and R, but I don't really see those as kind of software as much as they are just making sure that our students have the most up-to-date skills. So I don't know if I answered your question.
No, that's
Yeah.
Is there any last question before we can head to lunch?
I hate being right before lunch. Tell them I'm not here.
This is not the case.
Okay.
Many, many thanks.
Great.
Gentlemen.